All right, so for this example, we are looking at two different study techniques. We're trying to figure out which one is better for improving test scores. So it says for technique A, random sample of 80 students yields an average score of 85 with a standard deviation of 10. And for technique B, random sample of 100 students yields an average score of 82 with a standard deviation of 8. So it says calculate the probability that the difference in the average scores between A and B is greater than 4. So we're trying to figure out is there a difference bigger than 4 between the two, okay? So this is a just sample free response type question where you're going to need all of this information in order to guarantee full points, okay? So the first thing we need to do is state what we're dealing with, okay? So first up, we've got mu for group A. This is the mean score for students using technique A, and then same thing from UB, the mean score for students using technique B. Okay, and we are trying to find the probability that the mean for group A minus the mean for group B, is going to be greater than 4. Okay, so this is our communicating or stating what we're dealing with. Okay, so now we actually have to plan things out to set our conditions, make sure everything passes. Okay, so it says random. Okay, so let's check that first. So let's see. It says a random sample of 80 students and a random sample of 100 students. So we are good there. So both samples are random. Okay, and because they are both random, then we can find our combined difference where the means are concerned. So we're going to take the mean of group A minus the mean of group B, and we get our combined mean of 3. Okay, then we check for independence. Independent. Okay, and let's see. All right, so now this is for our 10% condition. Okay, so for group A, look at this. For group A, let's see, is 80 less than 10% of all students using technique A. Okay, and then for B, we gotta check is 100 less than or equal to 10% of all students using technique B. Okay. In order for us to sample without replacement, we're just going to assume that this is a fair assumption. We're going to assume that there's more than this is less than 10%. Okay, so fair or safe assumption, however you want to write that. Okay, so we can find our standard deviation. So x1 minus, or xa, sorry, and minus xb, sorry. Okay, and I'll write out the formula for you once. It's going to be square root of a over square root of, not square root, sorry, of na minus standard deviation squared of b over nb. So plug things in. We're going to have standard deviation divided by 80 plus standard deviation divided by 100. And this gives us a standard deviation for our combined, our difference of 1.378. Okay, and then for normal, okay, so take a moment, look through the problem. How do we figure out if it's normal? Okay. Well, for normal, we have got two things we got to check for. We can check for if our samples are both greater than 30, then we're good to go because of the central limit theorem. Okay, so let's check that. Our sample size of 80 here is greater than 30, and 100 here is greater than 30. Central limit theorem says we're good to go. So we can say both 80 is greater than 30, and 100 is greater than 30. That was a weird 3 there. 30. All right. So central limit theorem says the sampling distributions will be normal. Sorry, approximately normal. Can't forget that, sorry. All right, so we're good to go. Checked our conditions, now we gotta do our calculations. Okay, so again, we are trying to find the probability that our difference, sorry, it's gonna be a mu x bar 1, or A, minus mu x bar B. It's gonna be greater than 4, okay? And then when our combined distribution follows a normal distribution, that should be a mu here, normal distribution with a mean of 1 or 3 and a standard deviation of 1.378. Okay, so let's go ahead and standardize. So probability of mu x bar A minus mu x bar B is greater than 4. When we standardize, we're going to do probability that, let's see, 4 minus 3 over 1.378. Oops, sorry. We're going to have Z is greater than 4 minus 3 over 1.378. Sorry, got my numbers backwards there. Okay. So go ahead and write that out. It means we're looking for the probability that Z is greater than 0.726. Okay, and get my little graph. 0, we got 1, we got 2, we got 3, and I'm just going to quickly do it right here. We got 0.726. We're looking at this area here, okay? And that means we're dealing with a normal CDF with a lower bound of that 0.726. Our upper bound is positive infinity. Our mu is 0, and our standard deviation is 1. Okay. And this gives us a probability, throw that in your calculator, and we get 0.234. Okay, and then there we've got our, we've got almost everything done. Now we just got to make our conclusion, state our conclusion. So this is basically saying the probability that the difference in average scores between technique A and B is greater than 4 is about 23%. Okay. All right. So there we go. There's the notes. That's it for